In session 16 here, we're now going to address inverse variations. Up to this point, we've dealt with a direct variation. Here now we're going to be introduced to an inverse variation. Quickly here, here's a brief word problem. A blimp is on its way to a golf course to provide aerial shots during a televised golf tournament. It has 100 miles left to fly to reach its destination. There's enough information within this word problem whereby we could actually create a formula that would represent how how long it would take them going at an average speed. Obviously, if the blimp is going at a higher speed, it's going to take the blimp less time to get to its destination than it would if it were going at a slower speed. So the formula that we're going to use here is y equals 100 divided by x. Now, as a reminder, in a direct variation, as one variable increased, so did the other. However, in an inverse variation, the opposite occurs. As one variable increases, the other one decreases. It gets smaller. As one gets larger, the other gets smaller. And that's how they came up with the name inverse. One is the inverse of the other. And what we're going to do on the next screen is to take a look at how that happens. So let's go over there right now. Here's our same function, y equals 100 divided by x. Here's our table, x on the top, y on the bottom row. And what I've gone ahead and done now is plotted some points. X is going to represent the average speed of the blimp, excuse me, in miles per hour. So our x down here represents speed. It's a little sloppy there. Then our y-axis here represents time. So our x represents the speed and our y represents the time. Okay, let's take a look at our first value. Let's say that the average speed of the blimp during this 100-mile trip that it has left is 5 miles per hour. The question is, how long would it then take the blimp to go that 100 miles? Well, if we take 5, which is the speed in miles per hour, and we stick it back into our formula, what is 100 divided by 5? Well, 100 divided by 5 is 20. So when x is 5, y is 20. So at 5 miles per hour, it's going to take the blimp 20 hours traveling at that average speed to cover the 100 miles. So what I'm going to go ahead and do is just go ahead and plot that point. X is 5, so we start at our origin, come over 5, and then up to 20. So there's our first point. Now, let's say instead that the blimp's average speed for that 100-mile trip is 10 miles an hour. What then would be the amount of time in hours that it would take the blimp to make that 100-mile trip? Well, we take our x value, stick it back into our formula. 100 divided by 10 is 10. So when x is 10, the average speed is 10 miles an hour. It's going to take the blimp 10 hours to make the 100-mile trip. So we're going to come down here, start at our origin, come over 10 on the x, and then up 10 on the y. Next, x is 20. If the average speed of the blimp is 20 miles an hour, how long is it going to take the blimp to make the trip? Well, let's stick the 20 in. 100 divided by 20 is 5. So when x is 20, y is 5. So let's come over here to our origin, over to 20 for x, and up to 5 for y. And let's plot one more point. What if instead the blimp's average speed is 25 miles an hour? We'll stick the 25 in here. 100 divided by 25 is 4. So if the average speed of the blimp is 25 miles an hour, it's going to take the blimp 4 hours to make the 100-mile trip. So let's come here to our origin, over to x is 25, and this time y is 4, which is just a little bit less than the 5 there. So what we've done now is we've graphed the 4 points so far. Now there are more than just the 4 points, but those are just 4 that I've selected. Now, taking a look at this visually, do you think that this is going to be a straight line? Do you think that there's going to be a straight line that we could draw that is going to connect all 4 of these points here? Well, once again, we're using some uniform graph paper, and so you can use your eye effectively to tell that this will not be a straight line. It's going to be some type of a curve. So what you do here when you graph these types of functions and equations, you try to draw as smooth a curve as you possibly can. So I'm drawing it down like this. This curve now represents the graph of the function y equals 100 divided by x. Now, I said before that as one variable increases, the other decreases. And when you have that situation, you have an inverse variation. Let's take a look here. X represents our speed. As our speed increases from 5 to 10, did our y value also increase from 20 to something bigger? No, the y value decreased. So when x increases here, y decreases. That's what an inverse variation is. And the graph, once again, of an inverse variation will be a curve similar to what we're taking a look at here. Okay, as a quick review for inverse variations, as one variable increases, the other variable decreases. Next, the general formula for an inverse variation is y equals a divided by x. And as a quick reminder for a direct variation, the general formula for a direct variation is y equals a times x. An inverse variation is y equals a divided by x. Lastly, the graph for an inverse variation will be a curve. That's it then for session 16 on the inverse variation.